Hi everyone, welcome to another video. Today we are going to be doing an analysis of some data where we're going to be doing a site selection analysis. This is basically going to be comparing the distance that a customer travels to go access a service, and this information can be used to understand where there's a need to add another branch or basically expansion of a business. This could be used also by government services to identify the need of setting up infrastructure in areas. So starting off, we're going to be using a notebook by Colab. You can also use Jupyter Notebook. I have already started by describing the area that I'm going to be focusing on. So as you see on the screen, I have described the latitude and longitudinal position of these particular areas, and we are going to have our center in the Nairobi CBD, but you can feel free to customize it to an area that you'd like. And we are going to have centers also in Westlands, Rongai, Kasarani, Embakasi, and industrial area. So these areas are going to be where we are going to have our customers located, and also stores. We are going to have let's have 3 stores, and we're going to spread our customers in the different estates that we have. So jumping right in, we can start by I want to have a cell on top of this. No, it could be here. Let's just do. So we're going to do an import. We're going to import geopandas as GPD, which we're GPD, yeah, and we're going to import pandas as well as PD for handling our data frames, and we're also going to have a lot of calculations, so we are going to do numpy as NP. We're also going to use matplot and Seaborn for visualizations, but we can install those later. So I'm going to run this cell, and as it runs, we can start defining our stores. So we're going to define our existing stores, right? And we will say stores is a list, and we're going to have them as a dictionary, and we will store the store ID, and we will say this is S01. We also want to store, what else can we store? We can store a name just to make things easier. We will store, let's have Westlands. We will have Westlands, and then we will also describe our latitude. Let's do a tab on that. So this is Westlands, and 1 point. Okay, yeah, it's done a pretty solid job of storing that. And feel free to select, if you want to make it a bit more interesting, you can select different store locations from mine. But we're going with 3 stores, so these are going to be my stores, and we are going to do a return. We're going to return a PD dot. We're going to return it as a data frame. Stores. Yeah. So that is going to be a definition of our stores. Next, we are going to create a function that is going to, let's call it generate customer data, and we are going to set a default parameter of our number of customers. Number of customers, we will set it to a default of 1,000, and we're going to describe our center as this. Okay. Next, we want to set a seed, so we're going to say np.random.seed. This is going to make it reproducible. So as much as we're going to have random customers, we are going to be able to get the same random customers with each run. So we can run this, and then let's first generate the customers and we'll run them all together. So next we're going to describe the estates that we have. We're going to say, okay, so let's say estates, we say center underscore center is equals to at least, no, what, okay, we're going to have a list of these. Should we include just include Westlands? And so I'm going to pause, but I'm just going to populate with the individual latitudinal and longitudinal positions. So quickly, we have described our centers where we're going to have our clusters of our population, and then we are going to also have our customers is equals to an empty list for now. Then we're going to append, and we're going to start an iteration of an ID that starts with 1. So next we are going to have a for each center that is in estates center. What we want to do is we are going to the AI suggestion is actually a bit easier, but instead of using a uniform distribution, I want us to use a Poisson distribution so that we have a good or a realistic way of describing how the distribution is going to be. So in terms of the number of locals that are going to be in each center, we want it to be an np.random Poisson. So we're going to use a Poisson distribution because it's easier. So we're going to use our number of customers, and we are going to divide by the length of the estate center. So what is going to, it is going to have a random but still normally skewed distribution of our customers. So basically what it is going to do, we have a number of customers that is 1,000, and we have centers that are, how many centers? These are 6 centers. So it's going to do 1,000 divided by 6, but it's not going to be an exact distribution of what is 1,000 divided by 6. So the 1,000 divided by 6 is 1,666, which I could not do with my brain. But now the Poisson distribution is going to have like 150 here, it's going to 200 here, which is add some realism to our data. So then we are going to do for underscore, for whatever number we're going to have in the range of the locals, because it's going to be different with each iteration. What we want to do is we're going to describe a I just call a lat offset that is going to be an NP. So we want a distribution that is going to be an offset from that neighborhood, so it's going to be a bit different. So we're going to use a random. We don't want a uniform, we're going to use a normal so that it's a bit. So as you see, it describes the scale, and then you can look at the exact values of what we are providing here. So we want to use a normal, describing basically how much offset we want between where our customers are going to be positioned with the center with which they are. So we don't want any value of the log, and so we're going to have this as 0, and the scale we want it to be 0.01. This is going to be a distance of about a kilometer. It's going to be an offset. So we are also going to just, these are good suggestions. These are exactly what I wanted to do. So after we have the offset, what we are going to be doing is we are going to have, for each customer now, we are going to have the center. So we describe the latitude, and we are going to index the center, which the center is described with the latitude and the longitudinal position. And wait, my screen has just gone blank. Okay, sorry, my lights went out, but we'll continue from where I stopped. So what I have added is we're going to be returning our customers as a data frame. So I noticed we don't have any comments, so maybe you should be able to add some comments that provide a description. This is stores data, and this is our customers data. So realistically, if this was a real scenario, there would be more attributes for the customer. This would include maybe values like how much they have spent, what is the frequency that they come. So maybe we can find a relation between how frequent they come. Maybe if a store is closer, there's more frequent visits to that store, and other types of attributes. So but right now we want to just take into account the distance. So we have the customer ID and the latitude and the longitude. Yes, so we can go ahead and we're going to run our cells. We can save as customers data frame is equals to the name of our function. Okay. Okay, so customers data frame is equals to that, and we had parameters, so you can feel free to change the parameters if you want. And then stores df is equals to, what was the name of our function? Just call it existing stores. Okay, and then we can print our customers.df, and we can print our stores.df, and then we can run to see our output. So my engine had disconnected, so I just wanted to show you the error that you'll get if your engine has disconnected, and that just means that you should run all of them. So it just means that it's basically forgotten all the cells that we had run prior. And yeah, there we have it. So we can see we have 985 customers generated, and we have the latitude and the longitude. And as you can see, there is some small variation of each customer, and we also see the values of our store, their latitude, longitude, and their name. And so what we are going to do next, since this is just spatial data, we want to convert the data frames to geodata frames using geopandas. And let's start with the customers. You can call it GDF, right? GDF, yeah. And you see what it's filled out. We're going to go with that. So what it has provided, what it has filled is, it's really the same as what we returned here. We returned the data frame, so, and we put the data that we have. So right now we are converting our data frame to a geodata frame using this function, and we are supposed to provide our geometry, and we use points from xy function. And what I want to add as well is the CRS that we are going to be using, and we will be using the EPSG 4326, which is the WGS 84, and it is the same for our stores, practically the same. And we can print, or we can just I know the spelling of customers. GDF. Here I can do dot head. I wanted to print all of it so that we see how it looks, but we can just do the head. And this is conversion of the data frame to geodata frame. And if we run it, we will now see that we've added a geometry column of points. So as we recall, in our just spatial studies, we can have it as a point or as a polygon or an area. Okay, so unfortunately there was a part that I did not record, even though I thought I had recorded. But so what we are going to do is we're going to do a walkthrough. We're going to do a walkthrough of what I've done, and then we can continue. Just clear the output. I think I need to get like new equipment. Okay, so we have our geometry, and it's still the longitude and the latitude represented. So what we're going to do, we're going to be projecting to ESPG 3857, which is going to convert our latitudes to meters, which is basically easier to do, calculations with. So if we run this, we can see now the change in the geometry column. We see it's now larger figures, which we can't confirm, but I won't be confirming. I will just trust it. So these are the meters, and they're accurately converted. So in this code block, what we've done, we've created an array of the coordinates from the geometry column. Remember, we had done the projection for both the customers and the stores, so we have saved each coordinates separately so that we are able to do the calculation. So we've done an import of the cdist, which is from the CP spatial distance library. And once we're done, we've created a variable called distances, and we've applied the function taking the customer coordinates and the store coordinates. And this calculates the Euclidean distance between the points. So it does basically what it will do, it will calculate the point of a customer towards each store. So customer 1 to store 1 to store 2 to store 3, customer 2 to store 1 to store. So it becomes like a matrix of all these distances. And now what we are going to do is we are going to calculate the nearest store and the distance to the nearest store. So we will say the nearest store index is going to be, we are going to use numpy dot argmin is the one that calculates the index of the value, and we are going to say argmin, and we're taking the distances. We're going to take the distances and the axis. We don't really need to print that out, so I will do the nearest store distance as the next variable, and this is going to be the np dot, and we're just going to take the minimum distance between the matrix, and it's going to be the distance and axis one. Okay, so I've just tabbed it to see what we get, but this is actually what we want to do. We want to get the store ID, and we are using the stores. Let's just use the GDF to get the store ID, though it doesn't really have a difference if you use the data frame or the geodata frame, because the store ID, we didn't change anything to do the store ID. So it takes the value of the store ID and stores it as the nearest store, and we have the nearest store distance as well, which is just going to be the nearest store distance. We also want to, because this is going to be in meters, remember, we want to store the distance in kilometers, because it's going to be easier working with kilometers rather than meters. And this is going to be the nearest store distance divided by 1,000, right? Yeah. So we can do a head for this, and we can see our distance, and we see most of them have the nearest store ID is 1. I hope we have, it's suspicious all of them are close to store 1. Oh wait, okay, so we have some that are close to store 2, and hopefully the others have store 3 as well. And yeah, so what I want us to do next is we are going to save this as a function so that it's basically reproducible. And I will start with I'll start with we'll add a code block, then we'll define it, and we will say this is the calculating distance, and it's going to take the customers and the store data frame. That's true. And so what we want to do is we'll take this. Oh my goodness, I'm going to pause it because it's going to take a bit of some time to format. I'm not quick with the formatting, and then we will continue with our function. Okay, so I took some time to Google to see how I'm supposed to tab, and we can delete this code block. Yes, yeah. So this is like a cleanup, and we don't want to have the output. So we will do this. We'll do that. We'll just add a tab there, and I hope we won't need to you can add comments to separate to understand what each line of code is doing. Yeah, so we can do this and then we'll tab it. Okay, so this is a projection. This is a save coordinates, and then here is going to be calculate the distance, calculate the distance, and here we are find nearest store and distance. Right, so what we are going to return is we are going to return our customers df. We've also just because we've made the changes to the data frame. I think we should change it to use the geodata frame instead of the data frame. So we are going to use GDF here, GDF, and it's going to return a GDF, right? Customers GDF, yeah. Source GDF because it's provided here. That looks alright. And then next we are going to say the customer GDF is equals to the calculating distance like that. I think that should be fine. But we are going to remove this import from here, and we're going to bring it to our other installations here. I hope this won't take too much time, and we'll go ahead and delete our code blocks. Okay, so we have an error, customer GDF. Oh, it's customers GDF. Right, so we have our store ID, store distance, and as we wanted. Yes, so now we know the nearest store distance, so I want us to define a threshold of what we are going to describe as too long to walk. So like we have 1 kilometer, we have 1.8, and logically now you want to see like what threshold should we set to say that past this distance then these people need another store. So what we're going to do is we are going to visualize the mean and the standard deviation, basically the summary statistics, to have a good idea of the distribution of our data. And we're going to use the customers data frame, and let me use, I hadn't changed, but I think we can just run it again. I noticed I hadn't saved had used customer instead of customers, so I changed that, and just noticed that I've been freezing. I think I need a new computer. And no, we are going to use the distance in kilometers, and we are going to use the describe function to see. And we can see that we have a mean of 5 point something kilometers with a standard deviation of 4. We have a minimum, and 50% is 4 to going up, and we have the maximum distance being 14.7. So I think we can describe our underserved, we'll call them underserved customers. Let's use 3 kilometers, but we can use 3 kilometers. 3 kilometers will be our underserved. Okay, so what I want to do is we're going to just change this, and we'll see that is greater than 4.0 is going to be underserved. Okay, so that's just cast. I just want to see how that looks like. Okay, so we have it as a boolean. Let's see if we have customers GDF. So now we have a separate data frame that contains the IDs and basically information of which store and the distance that they have to go to get to the store. So to finish up, I have added a visualization code block. We have used matplot and Seaborn to visualize the distribution and the analysis. So we can see that the mean is even above the threshold. So we have a mean of 5.6, but we have a threshold of 4 kilometers. So that means that we should actually be planning on serving more customers by probably increasing the number of stores. We can see also that the store number 2 has the most amount of customers, which is even close to the mean, because it's approaching 500, so it's the one that is serving most people. And yeah, I think we can end here. This has been a pretty long tutorial. Probably we will also add another follow-up where we will be using machine learning or prediction to actually identify which location is the most suitable for setting up another store. So I hope you have enjoyed it. It's been pretty long. I hope you're able to fasten it a bit and follow through. I will provide a link to the notebook, and I'm also going to basically tweak it to be a bit more cohesive. Is it cohesive? Comprehensive with my comments and everything. And so yeah, thank you for watching. See you in another video.